welcome to 2.2.5, Part 2, where we talk about accumulator roles. So the variable role is the reason we're using the variable. Variables always have data for later use, but the why are we trying to remember something. The roles are the why we're using the variable. Roles are not syntax. Roles are different than type. There are certain reasons to use a variable over and over again. 8 roles cover 90% of variable uses for first-year programmers. We have fixed, accumulator, stepper, best so far, most recent, agitator, walker, and one-way flag. Now we're not going to go over all of them, but basically this is what they do. We've been using a lot of fixed variables, like we did in Part 1, where it's assigned once and we use it once and that's it. Today we're talking about how do we create a running total of our variables. And in the next one, we're going to figure out how to create a running list of our variables. So, of course, we've already talked about what a fixed variable is assigned at the top of the block of the code, which you saw me do in Part 1. An accumulator now is a running total. So this is to keep a running total of something, maybe the amount, the total area, the total amount of eggs, the total amount of money you're making. And then it's also its pattern. You're given an initial value before the loop. So you have to give that accumulator an initial value. You're going to add to it inside the loop, and the results will be after the loop. So I'm going to show you in our assignment. Again, all your answers are usually in the notes here. So let's go to Part 2, accumulator. And the very first area it wants you to do is take the sum of the area of these room widths. So it's giving us the variables here. Room widths, again, are 10, 20, 16, 30. And we want to output, ideally the computer is going to output 1656 when we hit run. So let's go over to my code that I have written here for you. So I started with listing my variable. So this is my room widths. It's a variable in a list form. And then I started with total area. So we don't know yet what the area is, but we know we want it to start from 0. Theoretically, we could be like, well, we already have an area of 40 and we want to add on to it. Right now we know that we have an area of 0, we're starting from scratch. So then we have our for loop expression, which will iterate through 10, 20, 16, 30. So again, we're still iterating, we're still repeating the for loop over and over and over again, but this time we're going to get just one answer. So we're going to take the total area, which is 0, right here. And we are going to add the width, this is the iterating part, to the second power. So 0 plus 10 to the second power, plus 20 to the second power, plus 16 to the second power, plus 30 to the second power. So this is the iterating for loop. Of course, then we want to print the total area after we've done the math. So we actually want to print what this total area equals now that we've added all of these areas to 0. Notice how I didn't actually define the function. Defining the function in Python is only necessary if you don't know the variables and you're going to input variables later. But because we already knew the variables starting out, I can actually save us lines of code and not define the function. So ideally, when you hit run, that's going to calculate to 1656. So you just now have to kind of describe how the lines of code relate to the accumulator pattern. And remember the accumulator pattern, if we went back to our notes, is right here. You initialize, right? You give an initial value, then you add to yourself inside the loop, and then the results are used after the loop. So here's your accumulator pattern. So you just have to describe how this code fits in it. All right, next code for part 2. So again, we're going to go to part 2 accumulator. And this time we want to define number of eggs, but again, we're not actually going to define the number because we already know the variables. Variable is right here, dozens, 3, 5, 2, 10. And so we can start with that. Again though, a friendly reminder, when you are done and screenshotting code, Command-Shift-4 for my Mac, it'd be, I think, Control-Shift-S for you. But you want to make sure that you're getting the code, the output, and your username. You can write your username in the code if you want, if it's hard to see, but I will not give you credit if I don't see your name on it, because you could easily just screenshot my screen, which would be silly because I'm on a Mac. That's pretty easy for me to tell. So let's go back to dozens. So I'm just going to scroll up because I wrote the code way down here. So here's our variable, dozens of 3, 5, 2, and 10. We start with an initial value of 0 because we don't have any yet. We don't have any from the previous time. We're like, we have 0 eggs. Now we want to figure out how many dozen eggs there are. So for each egg in the dozens, we are going to say dozen eggs equals 0 plus egg. So plus 3 times 12, plus 5 times 12, plus 2 times 12, plus 10 times 12. So again, we're iterating through the for loop. And we take dozen eggs plus, so 0 plus all of that times 12 over and over again. And then we're going to print the answer. And ideally, the answer comes out to 240. Again, if your answer is not coming out to what you think, what it says it should, then you probably have the code wrong and you should take a look at your syntax, making sure that everything is spelt correctly and that there are colons and parentheses where there should be and everything is tabbed in where it should be. Because what's really important with a for loop is that everything inside the for loop is tabbed in. Anything tabbed in actually connects it. Notice how I can put those together, because that's all one code. So tabbing in is actually really important. So when you see a tab in on my screen, you're going to need it for yours. So why is the accumulator pattern needed to create this function? What would be a good name for a variable playing the accumulator role? As you can see, I picked a name for the variable playing the accumulator role, but you could pick something else. I ended up just picking this one that they used. And then, of course, paste a snippet of the code. Again, make sure your name's on it. All right, this one is interesting because this uses the ASC2 values for characters. And it says that, so in the 100 words game, A is 1 point. However, in the ASC2, A is actually 97 points. So you'll see in the code that we have to minus 96. So ASC2 is really interesting. It just basically means like A is 97, B is 98, C is 99, D is 100, and it's just a way for a computer to read the alphabet and other symbols, including things like the $sign and the pound sign. But what we want is we want it to take the word bed, B-E-D, and we want it to spell out 254, B-E-D. So if A was 1, B would be 2, E would be 5, and D would be 4. We then want it to take those three numbers and add the total points together so that we know how we're doing on our game. So let me go and kind of screw them down here. So this is that first line of code. So our variable is the word bed. So we're defining that right off the bat. Variable is the word bed. Then we create a for loop because we want to get the value of each of those letters. So for letter in word, so for each of these letters in the word, we're going to print the ORD. And remember that ORD is what gets that value from the ASC2. So the value of the letter minus 96. Because remember, the ASC2 starts A at 97, and we want A to start at 90, or at 1. So we minus 96. So that is the code to get BED 245. Now we need to get the total. So now we have to create a total, or a points. This could also say points. It's just probably what Berkeley wants you to say, but again, this is just showing you that it doesn't actually matter what the words you choose are, as long as it's the same and it's consistent. So points, we're at 0. Everyone in the game starts at 0. So for letter in word, points equals, so 0 plus the ORD, or the value of the letter, minus 96. And so then we're going to iterate. Again, we're repeating the value of the letter B, minus 96, the value of the letter E, minus 96, and the value of the letter D, minus 96. We're getting that whole total, and then we're going to print the total. Ideally, your total for that should be 11. So make sure you answer everything in red, especially make sure you're answering everything that the turn-in says to answer. So for part 2, you needed 4B, 5A, 5D, 5D a screenshot, 6C, 6D, 6F a screenshot. Well, that was 2.25 part 2. Hopefully that helped. Please feel free to go back and watch the video. Pause wherever you need the code.